Tahir, Çelik, so I may invite myself to do my presentation over there. As you can hear me now, optimization of reinforcement steel in building construction projects. Actually, this is a master thesis prepared one of my students. His name is Abdul Ibrahim Kamara. Abdul, can you show yourself, please? Here is the guy. We just completed the thesis, and I would like to do the outputs of this master thesis. It is one of the important issues of construction industry, especially in Cyprus here. I have some so many years experience, and I know that we always use more than the designed amount of reinforcement in our construction. If we talk about waste stages of reinforcement in building construction, there could be unavoidable reinforcement waste. What are those? Cutting bar waste after optimization. You can make an optimization, but still, because the length of the bar is the standard 12 meters, some amount, some length is unfortunately unavoidable and should be wasted. Or expenditures required to reduce waste is superior in economy. You say, rather than doing optimization, spending time, engineering costs, etc., better not to do it. Avoidable waste caused by disorganized operating technique on the construction site, using excessive bars or longer than the required length. This is the most important part of it, probably. Unoptimized waste delivered 12-meter long bars were ineffectively cut. This is again one of the important points I want to talk. As a result, leftover pieces longer than 1 meter may be economically unusable. However, our statistics are clever enough. On construction sites, you may not find those pieces. They left in the concrete, so you don't see any base here. Rework is quite obvious. If you change your design and do it again, and design changes result is rework comes out. And production of defective or non-compliant with the standard of reinforcement. This is a bit unclear in this country because we do not do regularly what reinforcement are imported to this country. Sometimes some reinforcement could be out of standard. What do we do with them? Just waste. To minimize the waste, different stages, one is pre-design. You will prepare a feasibility study. What is feasibility study? Everybody knows this. You will make marketing, financial, and technical analysis and see which one is better for you. Structural design stage, selection of parameters among many. You know, many or most, probably most of us are using computer programs in structural design, and once this analysis is done, the program tells us you can use reinforcement diameter 14, 16, 18, 20, whatever, which one you are going to select. while selecting and optimization can be done. Construction stage, of course, application optimization system. I don't see any construction project in our country makes this optimization. Economic effects, amount of material to be produced, how more from the, amount of material to be purchased, to be procured. How more from the exact design view. You know, today the computer programs we use give actually us what is the exact amount of reinforcement required. But we always discuss how much more you are going to buy reinforcement from that amount. Disposing cost of waste material from the site and still fixed wages. Using excessive bars or longer lengths than the required lengths, actually more reinforcement is used in the construction, and you pay the cost of these workmanship, cost of these reinforcement. Normally, we used to teach calculation of BOQ by using Excel, something like this. So what do we do here? We describe what are the places for reinforcement, then diameters, then lengths from design. These are the exact lengths specified by project, and how many number of them, and then if there are similar elements. And then by using an if command, it goes and multiplies this, and this, and fix it under the diameter, 12 millimeter or 16 millimeter. Here goes and put under 16 millimeter. It's a simple, easy if command by using Excel. You can calculate all the reinforcement here, as you see, by multiplying them. So what I want to say here, by using Excel, you can create from each parameter what length or weight of reinforcement will be used exactly. These are design BOQ. From that point on, very cool. So one of the most fundamental definition of optimization, you can find many definitions in the literature. The one I like most is doing the most with the least. Reinforcement bars are manually or mechanically cut to the appropriate lengths and bent into the shapes specified on the project drawing. This is what the statistics do. Before cutting the bar cutting schedule needs to be developed and given to steel fixers. As many years ago, while I was doing my study and case studies in Britain, I have learned that in Britain, a steel fixer cannot start to cut reinforcement by himself. He prepares a schedule, he goes and gets the approval of the engineer, and then he applies it, which is not by our country here. Therefore, the process of generating a bar cutting pattern that meets demand while producing the least amount of waste is referred to as optimization. In literature, it is mentioned that the waste in the reinforcement can be more than 10 to 15%, more than that. In our thesis study, we use, there are many optimization program we can find. We use pro-optimization program. This cutting optimization pro is a software that creates cutting and nesting patterns for one or two dimensional materials. We could use one dimensional part of this one. Reduces waste and cost by specifying a maximum cut length from the C bar. It can import data from Microsoft. Here is a screenshot of it. What I can say, you can specify here what is the quantity you require, which diameter and where. And then you can specify your scope here, and it prepares you a graphic something like this, a schedule. It says you can use 16 millimeter diameter, you cut 3 of them, and these are you are going to cut pieces. And no waste here, no waste here. Here there is a waste. You can see. So this is a very easy, very quick, very practical application of this. And at last, you can get a figure for that. It is very easy for us to get this and then give it to steel fixer. Steel fixer will cut reinforcement like this and will reduce the waste. Here is a case study for a construction site, 2-story villa house, 230 square meter. It was me actually controlling this site. This is why I know all the details. We did the BOQ for reinforcement, and then this is what we obtained by applying property optimization program. As you see, we have all the detail here from which diameter, how many quantity, how will we cut, etc. And then this is what we obtained. That much reinforcement was actually what? That much 14,800 actually used on the site, and actually remain on the side of this, and required by Pro is this much. So the previous figure showed us that much reinforcement is enough for this construction according to the below quantity. So what we could obtain here, required exact reinforcement by design program, which for structure I used to design this, is 445 kilograms. Actually used on the construction side is 14,823 kilograms. Waste rate based on design program, that much. For optimization program, usage rate is this. So that means optimization also has a small waste, unavoidable waste, is 826 kilograms. Saving by optimization is 3,552 kilograms for reinforcement. So this saving is equal to around 24%. 24% reinforcement could be saved if you could use optimization, and if our steel fixer used the graphic prepared by the optimization. So in case of case study, waste rate is 24%. This ratio may change an amount depending on the selected reinforcement steel length. Of course, larger diameter, relatively more change. But how much? You can discuss this. Steel fixer, rather than cutting and generating many steel pieces of reinforcement, prefer fixing unnecessarily long bars in. So, in practical, if there is 2 meter length, and if steel fixer finds here 5 meter, it puts in 5 meter, it doesn't cut. If you cut, you will already see the piece there, so it will 5 with him. So, and you pay as owner the value of steel fixer. Therefore, the economical impact of the amount of steel fixing is not only purchasing, but includes workmanship price and value. Now, I got this data from Economic and Energy Ministry. Roughly, the reinforcement imported to this country. I don't know, 2021, they couldn't produce it yet, I asked them, but roughly around 100,000 tons of reinforcement we use in this country. So, applying optimization for reinforcement, we say somewhat 24,000 tons reinforcement. Including the steel fixer yield, this made around $28 million. This is year. Therefore, my recommendation is reinforcement cutting optimization should be obligatory in PLC. Structural design softwares can do a reinforcement optimization. During selecting the best reinforcement diameter, after selecting reinforcement diameter, make optimization and produce reinforcement traffic or cutting bar. I haven't confirmed this, but I heard that one of the design programs can do optimization is Tekla. Bin software Tekla can do this. I heard this. I cannot guarantee it, but it's what I heard. So it's not difficult. So here is, I don't know anybody related with the developing of these computer softwares for structural design. I think we need to consider them as well. And this could be maintained by a chamber of civil engineers through visa operation of the project. So it is very easy for us to say $28 million in this country per year if our visa office asks this graphic as well and put into the visa file. It is so easy, my friends, so I invite board of directors or chamber of civil engineers to consider it. Thank you for listening. I think at the end of for presentation, some questions may be answered.